in, we can add in the ability to have a stream. So this is a FIFO, first in, first out streaming mechanism where any data going over a particular set of subjects can be added into this kind of like hopper system. And then on top of the streams, we can build additional functionality, and these are known as kind of client-side projections. So we have this whole thing of KV store and object store all built on top as well, extending this kind of idea of this phone system, giving us incredibly powerful set of tools we can use to build some really, really complex systems. And ultimately, what we're trying to do is take systems that are built very, very, I'd say with high complexity, and they're built with just a lot of different requirements from a lot of different businesses and a lot of different teams. And we're trying to make it simpler and smoother. So as we take this mental image of, all various bits of software stacked on each other and some horrendous, dependencies, what if we can flatten all of that and make communication really, really simple? So the idea is if NATS becomes our kind of communications broker, and we can do different patterns like request reply and pub sub and streams and key value and object store, we've drastically simplified how a system communicates east to west, north to south, and at a global scale as well. And that allows us to remove the number of components in a given system. So this is like putting money in the bank with extremely high interest. We can take out RabbitMQ and Kafka and Redis and all these other different things. We can use NATS as both the messaging system for both the KV, and you get the idea where I'm going here. So we can flatten a design of a system with NATS, which means it's operationally much simpler. You get a high return for some investment around NATS. And once you're up to speed with NATS, the weird thing for me was it changed the way I think about writing software and building systems. Once I made my kind of thought process NAT-centric, building a distributed system is easy. I can deploy very simple programs, whatever. I can deploy it on FlyIO and AWS and Azure, and these things work together. So NATS allows us to do things like multi-cloud without really even uttering the term multi-cloud because of the power of what NAS can do. And therefore, we had to make it easy to adopt. So we've got something like 11 official client libraries with a wide feature support. And what I mean is it's kind of like 90% to 100% feature support of the server. And then some more, say 30 plus community contributed libraries with varying coverage. And most of the team here at Synadia, we're all Gophers, so we're very familiar with Go. And then Rust, C, Python, Ruby, Java and JavaScript as well are the main ones. And the interesting thing is we can change the way that systems are inherently created by using these libraries because of what the NAT server can expose. And that can be via WebSockets, or it can be via client code that you can embed into something like a browser-based app, or something in C that's down at low level on a factory floor or in a vehicle or even on a satellite. When we talk about this notion of going using subjects and not sockets. So instead of thinking, well, how am I going to get all of my things to talk to each other? And you think about deploying like a network fabric, for instance, where you're trying to bridge things on Kubernetes, but you also want some public cloud involvement. So you've got some on-premises data centers, and you want this thing to stretch and be elastic across your public cloud infra. This whole notion of subjects becomes really, really important, and it becomes really pivotal on location transparency. We care about the what, not the how to connect things. So from a most simple sense, we have clients, and a client is your logic, it's your code with the NATS library in the language that it supports. And then the clients connect to a NATS system. Now, a NATS system can be a single server, it can be a cluster within a region, within a country, and it can be a super cluster spanning the globe. And we certainly have got customers doing that today, literally global spanning single NATS clusters. But ultimately, what it allows us to do is once a client connects to one or more endpoints, then the NATS server brokers connection between every other system, providing, of course, you have authentication and authorization allowing you to do that. So in this mode, we can have one client publishing onto, let's take the cliche subject foo, and we can have another client subscribing to that. And we could have one in India, one in the UK. And in fact, I'm going to be brave in a moment and see if we can actually do this from the room in a few seconds. So if anybody in the audience has got the laptop with them and you've got access, you've got the NATS client, it would probably be a good idea to see if we can pull this off. But I'll get there in a moment. What I'm trying to say really here is that we have an immense amount of choice for NATS, so we can deploy in different modes, different clusters, and we can use it very much to flatten the complexities. And now NATS scales. Core NATS, when I talk about core NATS, I'm really talking about request reply and pub sub patterns. We're talking, tens of millions of messages per second and north of that. And then when we're talking about client connections, we typically try and scale things around 200,000 client connections per server. This is not per cluster, just to make sure the system's not going to die under load. The summary really here is we can build very, very simple things to extremely let's say highly connected, and then hundreds of thousands of connections, all global, with intermittent connectivity as well. So if you think about 4G, 5G as a system dips in and out of connectivity, we can even deploy these kind of like leaf nodes, which allows the system to operate without connectivity and then catch a remote system once connectivity is restored. We've got a lot of different options. So oh yeah, and the last point really is it's client server ultimately. NATS takes care of the heavy lifting, which means you can write very, very simple code. So NATS functionality, we have ephemeral pub sub and ephemeral request reply, which is really, really powerful. A lot of companies and a lot of customers actually only use the ephemeral side. So what I'm going to do now, I'm going to flick screens and I'm just going to NATS itself is a plain text protocol, much like SMTP, FTP, and HTTP. Forget all the SSL and TLS and all the other mechanisms added on later. These protocols are plain text protocols. There is a set of definitions for the remote procedure call, for all of the interactions, for how the payloads traverse the systems, and NATS is no different. So NATS happens to be the name of the protocol, the name of the CLI client, and also the name of the OSS project and the server, just not to confuse things. So NATS as a protocol can be driven, if nothing prevents you, like again, authentication, authorization, or encryption, NATS can be driven via telnet, which is interesting, but I'm not going to do that here because I don't have suicidal tendencies. I'm going to use the NATS CLI client, and the NATS CLI client, like all good CLI clients, exposes the inner workings of the NATS system and allows us to drive the whole thing via command line interaction through a bunch of verbs and switches and some other fields. Now, what I'm going to do first is I'm going to show you the most fundamental basic block, which is a publish. I'm going to do NATS publish to the subject porridge, and hello, I like porridge. Now what's going to happen here is I am going to hit return on that and do it straight away. Now this has a at most once delivery guarantee. Now what that means is if I have interested parties in the subject porridge, then on a publish the interested parties they're going to get at most once a hello, I like porridge payload. Okay, very, very simple, nothing groundbreaking there, and all it's doing is showing fan out. Now, I've got no subscribers, but the message you note was still published. It doesn't turn around and say nothing was interested, so I'm not going to publish it. It publishes it anyway. And this is exactly like the phone system paradigm that we spoke about. So what I'm going to do now is I'm going to bring a subscriber online, or two subscribers online. Now, these subscribers connect again to the same demo.nats IO demo cluster. These are location transparent, as in we don't really give a damn where these systems run, providing they can get to the demo.nats IO server or the cluster. Who cares where they are? Now, one of these clients could be on FlyIO, one could be on AWS, one could be on Azure, one could be on Kubernetes running in your mom's basement. We don't really care about that. NATS doesn't care. So providing authentication, authorization, and encryption allows these clients to connect. We're good. So let's do this. So let's bring a couple of subscribers on and let's tell them how I feel about porridge, which apparently is I like porridge. And truth be told, I have no idea how I got onto the porridge thing. So this is likely to become a thing. I don't really know how this happened, but it happened. So let's just go with it. So hello, I like porridge, and we've just done a fan out. So now what I'm going to do is I'm going to flip this around, and I am now going to do the traditional Oliver Twist. Please, sir, can I have some more porridge? And again, I don't even like Oliver Twist, so I don't know how this happened, but it did, so let's just go with it. So NATS reply, porridge ask, sure, here you go, it's Christmas, enjoy. And I'm going to do another one where NATS reply, NATS reply, I keep doing this, NATS reply, no, go away, you've had no porridge. So I was just trying to use my my CLI tool there with auto completion to help me go through my history, because I'm not very good at typing when I'm being recorded. So we've got one reply, sure, here you go, it's Christmas, enjoy, and we've got another reply, no, go away. Now, what's going to happen? It's going to be the fastest response wins. They're not in a queue group, and a queue group allows us to do arbitrary load balancing within a bunch of connected clients. And they both have they're in an inbox group called NATS reply 22, which means as soon as it gets the request, or you could think of it as a unicast publish, they both reply directly back to the inbox, and the fastest one wins. So let's see what I'm going to do. Am I going to get porridge or am I not? No, go away, you've had enough porridge. Well, that's disappointing, but it worked. And we can see here that the second replier, you know, it won with an RTT of 253, or excuse me, 253 milliseconds. Now, you're kind of thinking again, well, this isn't very interesting, is it, Dave? Well, actually, if you think about this laterally, these repliers, could be custom code. It could be your web service that no longer has a HTTP front end, but a NATS front end. And providing these clients can connect back to NATS, they could be anywhere. They could be on a Raspberry Pi in your office. They could be running in your developer machine. We don't really care, which means suddenly the networking stack looks a lot simpler and becomes a NATS-centric system. So let's clear down this and just make our screens tidy for what's about to happen next. So the next one I'm going to do is I'm going to do nats kv add, and I'm just going to use the word India because it's simple for me to remember. So I've added a kv bucket. Now a kv, the key value, much like etcd and Redis, is a projection on a stream. And whilst we'll cover streams in a moment, I want to cover kv first because, it's kind of fun, and we can do all sorts of things with kv, like we can watch them as well, much like a consumer on stream. So I'm going to do nats kv put into the India bucket intro, I am Dave. Nothing spectacular here, and I am Dave. So that basically says, okay, I am, I put my message in and I've got something back, and it's kind of like a simple echo verification. What I can do now is I can do nats kv get India intro. And it should say, I am Dave, and that was done 18th of December, 12:23. And note, I've re-recorded the demo because I just wasn't very well on the day and I messed it up, which I'm terribly sorry about. Now, let's do something more interesting. So we can do nats kv watch India intro. So now I'm watching. So now if I do a put, I am Dave, eater of porridge. I don't even eat porridge. Again, this has become a weird thing, hasn't it? And what's happened, I've updated the key in the KV, and my watcher has just alerted my client that something has changed. Now, this is interesting because, again, if you think about lots of applications that pull state or poll state, we don't need to do that anymore. We can literally just wait there and be told that something has updated, which is particularly useful. So KVs are performant, shardable key value stores, which are projections on top of the NATS system. Now, the next thing I'm going to do is I'm going to add an object store, which is exactly like S3 on AWS or R2 on DigitalOcean. So NATS object add, you know what, I'm just going to call it India because my brain apparently can't handle much else at the moment. NATS object put India talk. So this is the PDF deck that you're seeing right now, and it is now on the demo server if you wanted to get that. And you can actually get it just by nats object get India, then the nats Synadia intro. So let's do nats object ls India. And what I've done here is on the object store is I've just said give me everything in there. Give me the give me a directory view, or give me a list of everything that's going on, or everything that the bucket has, sorry, to be more specific. So you can download that by doing get. You don't need any credentials to access that. And the object buckets are interesting for processing pipelines, for storing files exactly like you would do on any other system. I happen to like them and think of NATS as like a waterfall system where I can start at the top with publishes and requests and replies and all these kind of things, and then trickle down into cache layer, useful features like KV, and then let's say I am doing downstream processing as messages hit streams and you know, my other NATS entry points, I can take aggregate data and put them into, or put the process data then into an object store, either for, you know, async processing like in analytics, or for backup systems or that kind of thing. So let's go a little bit further now. Now I've shown you KV and I've now shown you stream. Sorry, an object. I'm going to show you a stream. So NATS stream add India. And I'm going to do India.chevron, which is basically like a wildcard. I'm going to put it on file, replication. You know what? I'm just for the sake of brevity for this demo, I'm going to go through and accept all of the defaults, which is absolutely fine. And it's going to have a replication of 1. And the discard policies are, which means when it starts to fill up, the oldest messages will get pruned first, and we've got explicit acknowledgement going on as well. Okay, so let's put something into a stream. So I'm going to do nats pub india dot Dave. Hello everyone, it's great to be here. Now you'll notice here that our guarantee kind of paradigms have changed, or guarantee semantics have changed, and we've gone from at most once delivery with a stream, and then we've gone to at least once, because what happens when we add a consumer onto a stream, we can deliver this more than once to interested parties. And then Jean-Noel on our team, he's written an excellent blog post as well on something called infinite deduplication, which gives you an exactly once paradigm across your message delivery. So now let's go and take a look at the stream. So NATS stream, and we can cheat here a little bit. We can do this. We can actually view the content to the stream without a consumer. And what the CLI client actually does, it creates a consumer under the hood, or an ephemeral consumer under the hood, replays the data, and then it kills itself. So hello everyone, it's great to be here. But what we can do one better than that. We can do nats consumer add, and I'm going to add it to the India stream, consumer name, India, delivery target. So I'm just going to go through, I want newest messages, which will give me, obviously the consumer will be able to deliver new messages and ignore the old ones. But you know what? Let's just do all. Let's start all the way back from sequence 0. Acknowledgement policy is explicit. So if I consume a message, I need to tell the consumer it's been acknowledged before I get the next message. Instant replay policy. I can actually replay them in the order and the time that they came in. Sorry, not order, in the time that they came in, or I can play them instantly back. So for instance, if I wanted to replay and try and solve a bug maybe that my system was having, I could replay the messages in the stream is in exactly the same time differences as when they hit the stream, which is useful. You know, if I've got like a grey bug that's happening under certain conditions, I can get the messages to come in exactly again in the same time spacings to try and help me resolve that particular bug. So, but I want everything instantly. I don't really care about that. Filter stream by subject, which is interesting. In 2.10 we could have different filters on a stream, which was really useful. Maximum allowed deliveries. You know what, I'm gonna go again for brevity, let's just go through all of the defaults, and then I can do nats consumer India. Is it next consumer? Right, okay, next is our keyword, so I want the next message, and it's on the India stream and on the India consumer. And then hello everyone, it's great to be here, and it's acknowledge the message, which basically means if I do another next, I won't get anything back because there's no message there, and it will just time out. Streams are incredibly useful things, and we can have obviously replication factors on them as well. And with a stream, you get FIFO ordering, or first in, first out, and you can have multiple consumers working on a stream, or you can have one consumer working on a stream with a number of messages in flight, so a number of different clients can use the same consumer, or you can have a high number of consumers and maybe do like a one-to-one between your downstream clients. So hopefully this demo has been interesting for you. We've took you through PubSub, request reply, KV, object, and at the very last some streaming basics. Now again, All of this is the most fundamental set of NATS building blocks, and everything else is typically built on of these features. And there are lots and lots and lots of configuration options. I can't give you all of that in like a 13-minute demo. There is way too much to cover, but hopefully this has helped you understand maybe some things you didn't as you walked through the door. Let's go back to the slides. Going to be safer for me to do that. I don't know what's going on. I did rehearse before I came here, but with the KV and the object store, it gives us this ability to go kind of polyglot against features across anything that you're likely to require in design in a kind of a modern web stack or a set of modern distributed applications. Sorry about the demo server. No idea what's going on there. You can try all of that yourself, though. Either stand up a NATS server locally on your machine, or on a good day, maybe try the demo server. So I don't want to take any more time than I have to. I think I had 15 minutes and I'm probably kind of way over that. Hopefully, if you didn't know anything about NATS, now you do, just ignoring the demo that went a little bit sideways. We actually have, so this is Synadia, we actually have our yearly Rethink Connectivity Conference on January the 11th next year. If you're interested in any of these topics and what Synadia is doing commercially as well, please come along, and the link is here. So it's a Crowdcast link. We've got some good docs, examples as well. So we've got NATS by example. So examples.nats.io will show you how to do a lot of this stuff in whatever language that you're using. We also have a community Slack, and that thing grows astronomically. The numbers are just off the chart. So come and say hello if you're not already on there. And if you like gaming, we actually built several games using NATS just to show how well this thing works. So we've got natsdrone.fly.dev. So maybe in a break, get your phone out, scan the QR code, get on the game as well, because I can assure you it's a lot of fun as you shoot drones with your phone. You can also head over to synadia.com. We've got a NATS FM podcast as well. Feel free to listen to those. And at that, I will hand back to the stage and say, thank you very much again for the opportunity to be here, and I hope you have a great rest of the event. I'll be in the background to help with questions as well. So thank you, and yeah, have a great rest of the event.
Thank you so much, David. So there are some questions on the chat. I think if you can address those.
Okay. There are two questions on chat. So hey, David, is there such a thing as dbref in NATS, or is there another way to use reference of some key value in other KV bucket? So this is from Rahul. If you could answer this.
I've got to be honest, I'm not sure I fully understand the question. Sorry.
Yeah, right. This is maybe Rahul, you can just put as to what dbref you mean. But meanwhile, let me ask the other question as well. This from Tejas. Is NATS suitable for big data applications or analytical workloads?
That's a great question. I think it depends how big of data that we're talking about. So the object store can handle gigabytes of data. So if we think about a pipeline where we have messages hitting the NAT system, those systems could go into a stream, and then asynchronously the stream could generate large data payloads and put them into object. It will allow you to build a pipeline system for those kind of workloads. But what NATS isn't is a database, and it's not a unstructured, kind of NoSQL style database either. So what we typically see is companies will pair together, kind of SQLite or a SQL system to allow you to do those, but there's no reason why you can't build, like I say, reasonable pipelines. Sorry, a bit of a vague answer maybe, but I think normally it depends. But yeah, I don't see really why not. I can see more questions coming through as well. So we've got things like NATS. Go on, sorry, go for it. I've just lost audio if you can hear me.
Hey, David. Am I audible now?
Yeah, there we go.
Perfect. So this is Rohit from Tanla Platforms. I think you had a call with our company sometime last week. So my question is on the transactions per second that NATS as a cluster can support at even point of time.
I think it depends what dimension that we're talking about. We're talking about jet
5
stream.
node, yeah, 5-node cluster of NATs with Jetstream enabled.
So for things, and it's relatively difficult to answer because it depends on the dimensions. So if we're talking about size of message, numbers of messages, but let's say if your messages are in the kind of low orders of hundreds of bytes with Jetstream, and let's say you build a stream. Say it again, sorry?
We can assume the message is 4 KB in size, and each of our node is 16 core and 128 gigs of RAM with 1 terabyte of storage.
Okay, so it depends on two things then. One is the speed of the disk storage, if it's a disk-based stream or if it's a memory-based stream. The memory-based streams are going to be much higher in performance. But I mean, it's going to vary. I mean, I hate these kind of questions just because I can answer it two ways and still be wrong. But you're going to be talking hundreds of thousands of messages per second with Jetstream, probably 4 KB if you're in a memory-based stream. And obviously latency of the network is important as well. So for something like AWS on kind of cheaper VMs, you'll find throttling will slow that down anyway. If these are your servers and on your network, you're going to find higher performance.
Thank you.
No worries. Sorry about the vagueness as well. It's relatively difficult just because there's so many moving parts.
Yeah. So is there a Kafka Connect equivalent in NATS ecosystem?
Is there a Kafka, what was that, connector?
Kafka Connect, yes.
So I don't know if there's one out there in the open source community. Typically, instead of working with Kafka, I think it's safe to say that we prefer to remove Kafka from a system and just rely on NATS instead.
Okay. I cannot hear.
I'll repeat the question for you, David. The question is there?
Just lost stage again. Sorry, I just lost you there for about 20 seconds.
Yeah, the question is there something in NATS that's analogous to Kafka Connect, the framework?
Right, okay, I understand a bit better now. Right, I am not familiar with that, so I can't fully answer, but Jean-Noel, one of our field CTOs, is in the chat.
I think we have time for one more question. Just going back, the guest is Rahul. So their question was, can we use an object reference as a key value, as a parameter for some other KV in a bucket, more like a pointer?
I'm with you. Yeah. So providing it can be represented as a text or as an ASCII string, then sure. Yeah.